Hey students, so we are now on 6.2 notes solving easy exponential equations. Okay, so before we start, let's go and fill in our chart. I'm going to bring up my key really quickly just on the chart here. I do have a typo here, students. This is supposed to be a y variable, not a both. Okay, so one is an x exponent and the other one, the exponent's y. So the first line said, if b to the x power, students, equals b to the y, okay, then x must equal to y because the bases are exactly the same. So how do we solve? Step number one, isolate the base. Get the base all by itself. Step number two, now rewrite each base as a power of a common base. I mean, get the base to be the same from each side if possible. Number three, set the exponents equal to one another because now the bases are the same. And step number four, solve as a simple equation. So examples 1 to 8, it's all going to be solving, okay? So example 1 says 3 to the 5x minus 1, students, and no calculator on these easy one. No calculator, okay? All right, so the base is 3 to the power of 5x minus 1 equals 81. Now over here, 81 could be thought as 81 to the first power. Well, the base is 3. Over here is 81. They're clearly not the same. So we are going to break 81 to 9 times 9. And 9, guys, is 3 times 3. So those are prime. This is also 3 times 3. So as you can see here, 81 is going to be 3 to the 4th power. And then over here, we are going to drop down 3 to the power of 5x minus 1. Now, since the bases are now exactly the same, we can drop them and just take the exponents and make them equal to each other. That's how easy it is. So the exponents are 5x minus 1 equals 4, and solve it as usual. Plus 1 to both sides, so that's going to give us 5x equals 5, divide both sides by 5. So guys, x is going to come out to be 1. Bam. Nice and simple. All right, go to example number 2. Number 2 says 4 to the power of a plus 3 minus 7 equals 25. Now, as you can see here, on the left side, the base 4 is not isolated, so we have to isolate that by removing anything that's around it, okay? So we are going to have 4 to the power of a plus 3 equals 32. Well, guys, base 4 here and base 32, they are not the same, so we are going to see if we can break that down. 4 is to the power of 2, so 2 squared equals 4, and we have an exponent of a plus 3. Now over here, 32, if we were to break this down, that's 2 times 16, okay? And 16, guys, is 2 times 8, and 8, guys, is going to be 2 times 2 times 2. So as you can see here, 32 is 2 to the 5th power. Now, power to the power, we are going to multiply the powers first, as you can see. So it's going to go 2. When you multiply the power, we are going to distribute. So that's 2 to the power 2a plus 6 equals 2 to the 5th. Now the bases are the same, so we can take the exponents and make them equal to one another. I'm going to go to the right side to continue this work. So 2a plus 6 equals 5. Subtract 6 from both sides. It will give us 2a equals negative 1. Divide both sides by 2. A is going to come out to be negative 1 over 2. Bum, bum, bum. All done. Nice and simple. Okay. Now, example 3, let's roll over. This one's a nice and simple one. I would like for you guys to take a minute to finish that up and give me what x equals. Remember, if the bases are the same and there's only one base on the right and one base on the left, you can drop the base and just make the equation equal to one another and solve. All right, once you have the answer, write it in and box it up. Let's go to example number 4. Example number 4 says 3 to the power of negative 2n plus 1 times 3 to the power of negative 2n minus 3 equals 3 to the power of negative n. Now guys, we have 3 bases, and all 3, which is nice and simple, but on the left side, there are 2 of them, okay? So we cannot, again, I'm gonna repeat, we cannot drop the bases right now. But when you guys are multiplying, we are going to add the bases on the left side. So multiplying and the base is the same. First, we need to combine the exponent, okay? So add that first exponent, and then I'm gonna add the second exponent. On the right side, there's only 1 term, so we do not need to do anything for it right now. Now, when we combine like terms, that's gonna give us negative 4n. And then these right here, 1 and negative 3, that will give us negative 2, and then equals 3 to the negative n. Now the bases are the same, students, so we will take the exponents and set them equal to each other. So 4n minus 2 equals negative n. I'm going to move the n to the left, and no, you don't have to move the n to the left. You can technically keep them on the right if you want. Oops, whoa, don't do that. It's a negative 4n, so guys, I need to add 4n to both sides. I forgot the negative. I miscarry that, so make sure that's a negative 4n. So to undo negative 4n, we're adding 4n to both sides. All right, so that's going to cancel. Over here, we should have positive 3n equals negative 2. Divide both sides by 3. So final answer, n is going to be a negative 2 over 3. And box that up. All right, let's move on to example 5. Ooh, this one's a little difficult, right? Because we have 1 over 25. But fear not, it's really not that difficult. All right, base 5 to the power of x minus 4. Well, 5 is already a prime number, guys, so we do not or cannot break it down anymore. But 1 over 25th, students, is the same thing as saying 25 to the negative 1 power. Those are exactly the same. Well, 25, students, is really 5 squared. Look at that. Look at how we broke down the 1 over 25th, right? So power to the power, we are going to multiply the exponents out. So that's going to be 2 times negative 1 is negative 2. So we are allowed to convert that down now to the common base. So these 2 bases now exactly the same. So all we have to do is now drop them and make the exponent equal. Add 4 to both sides. So if we add 4 to both sides, negative 2 plus 4 is now positive 2. Let's move on to this one. Okay. 6 to example 6. 9 to the power of y plus 7 equals 243. So currently, let's break down 243. Remember, we know that's not divisible by 3. I'm sorry, by 2 because it's an odd number. Now, to determine if it's divisible by 3, you're going to add up all of the digits. So 2 plus 4, that's 6. 6 plus 3, that's 9. So 9 is divisible by 3. So we know 243 students is divisible by 3. In fact, it is going to be divisible by 3 81 times. So 81 is 9 times 9. And 9 is 3 times 3, okay, for each one. So as you can see, we got 1, 2, 3, 4, and 5. So, oops, look at that, just disappeared. Okay, so 243 is 3 to the 5th. Now 9 is a base, but I'm going to break down 9 to 3 squared and then drop my original power back. Power to the power, students, we are going to multiply the exponents out. So it's going to say 3 to the 2y plus 14 equals 3 to the 5th. Look at this beautiful question. The bases are exactly the same, guys. So we are just going to drop them and write 2y plus 14 equals 5. Subtract 14 from both sides. So it's going to be 2y equals negative 9. Divide both sides by 2. So y comes out to be a negative 9 over 2. Look at that. No calculator. All of it is beautiful fractions, right? Amen. Let's go to the last 2. 2 last questions, students. Okay, they're both you tries. Now, number 7. I want you to look at example 4, right? because number 7, let's see example 4. Yeah, right here. Notice how we have, on example 4, we have 2 base of 3s on the left side. We cannot drop the bases if one side is imbalanced, okay? So for this one, we got 2 bases of 2 on the left side. So currently, you may not drop the bases. But what are you going to do first if you are multiplying and the bases are the same? Did you say add the exponents? You are correct. Adding the exponents. I'm just going to drop down this side. Nothing, we're not doing anything right now on the right side. Okay, so now on the left side, that will give us negative 1x or negative x. That's exactly the same, okay? Now we have 1 base 2 and 1 base 2 on each side, so we can drop the exponent. So now drop the bases and make your exponent now equal to each other, okay? What we could do is we could go in and add x to both sides. Yep, that's totally fine to do. Now this is going to give us 0 equals 3x. Obviously we have to divide both sides by 3. But guys, 0 divided by 3 is what? Yep, it is 0. There you go. Okay. Last example, it's saying 4 guys to the power of 3x minus 1, okay? So this is going to require for you guys to think a little bit more because you need to go backwards a little bit. Our current base is 4, okay? So I want you to think for a second, 4 to what exponent is 1? So 4 to what exponent is 1? Because on this side, we're not going to do anything yet. We're just going to copy it down as is. I hope you said 4 to the 0. If you said 4 to the 0, then you are exactly right. So now that you know is 4 to the 0 equals 1, now we can drop the base 4 and then just keep the exponent and make them equal each other. So 3x minus 2 equals 0. Add 2 to both sides. And that's going to say 3x equals 2. Divide both sides by 3. Look at that, guys. X equals 2 over 3. Beautiful, right? That's all done.